Hey everybody, welcome back to the channel. Can these tiny little lithium batteries cause explosions and blow your arm off? Well, let's talk about it in today's video. Today's video is a special request from Southern Prepper 1. Now, if you're not familiar with who Southern Prepper 1 is, I'll have a link in this video's description so you can find his channel. But anyhow, due to the explosions overseas from the pagers and all that that's going on, he asked me to discuss lithium battery safety and could, some device make these things explode like those pagers did. So that's what I'm going to go over. First, we need to get some data. I was requested to bring you this video, so I had to go scrounging around for some small lithium batteries. And this is the smallest lithium battery I got. This is a lithium poly. Now, I'm assuming this is what those pagers or electronic devices similar to that used to using, stuff like that, lithium iron phosphate. But with that said, let's just do some math on this first. This is a 2.59 watt hour lithium poly battery. So first, to determine if this holds enough energy to cause an explosion, we need to convert this watt hours over to joules. So this little battery, 2.59 watt hours converted to joules, has 9,324 joules of energy in this little tiny compact package. Very impressive. And the battery weighs roughly 3 grams. You may be asking, what does that have to do with the price of corn? Well, I'm going to show you. So using joules as our common energy measurement, 1 gram of TNT explosive is equal to 4,184 joules. So the little li-poly battery will convert everything over. I didn't show my work, but it's just basic math. So the 2.59 watt hours of energy in the little li-poly battery is equal to 2.28 grams of TNT. So there's as much energy in that little battery as that much TNT. Quite impressive when you run the numbers. You'll have to excuse me going back and forth between SI units and English units, but I'm trying to give you references that you'll understand. So let's take this 320 watt hour or 100 amp hour lithium iron phosphate cell right here. That's 320 watt hours. It weighs roughly 5 pounds. So that's 1.152 million joules in this. And that's equivalent to 275 grams of TNT, which is 9.8 pounds of TNT energy equivalent in that cell right there. That is a lot of energy. So I'm not an explosive expert by any shape of the imagination. I have zero experience with any kind of explosives. But I do know that explosives can release their energy instantaneously in nanoseconds, whereas a battery, due to its construction, would not be prone to immediate release in the term of, nanoseconds, milliseconds, things like that. It would take a little longer for this energy to dump out. Of course, you could short across the terminals and you'd get, nice fancy short circuit. A lot of energy would flow through there, but it would still be in a longer time format than an explosive would, where this is already in a high state of instability, where this is very stable and safe 99% of the time. And also lithium batteries, like lithium iron phosphate, is a very safe battery, puncture resistant, you'll release gases and things like that. And, lithium iron phosphate does not have a reputation or very much documentation of exploding. Usually lithium batteries off-gas and catch stuff on fire and burn. That is propensity for lithium, is to burn. Now, lithium is a highly reactive metal, but with the compounds that these batteries are made out of, it's stabilized. So, water and things like that, like raw lithium, you dump raw lithium in water, that's not going to happen with these cells that are commercially constructed like this. So I know we went around the world, but I wanted to let you know about the energy density in these batteries, but they have their safeguards. Even this little li-poly battery right here, check out the little vent holes in the top. That goes right down, into the battery. It's got a little diaphragm in there, so if this battery was to be hit with some kind of, let's just say, electronic warfare device. I think that might be some of the speculation with what's going on. If it had some kind of device to, manipulate the electrons in here and excite them and get them all hyperactive and overheat them, well, the vents would 99.999% likely take care of anything like that would happen. That's what those vents are designed for. They're designed for the worst case scenario that these batteries can encounter, to relieve that pressure to keep the cases from rupturing. Now, it's just the thin layers of aluminum that hold these together, but they're engineered to be safe. So whatever electronic measures, if that's what went on, I mean, you'd have to have something that would, overexcite and go past what that vent could handle. But then again, I don't think that is plausible. I mean, anything is possible, but I don't think it's likely. And even the case on these is so thin, it's only equivalent to a few layers of aluminum foil. So if you did have an overpressure, would it have enough explosive energy behind it? And you'd have to get the energy dump to dump like that out of this lithium. And I just don't think that could happen. Even if you got a lithium iron phosphate cell, which is the safest cells out there, even if you got it excited, look at that huge vent hole you got right there. That's 1 inch diameter. So I mean, that's something goes wrong in here, you got to overwhelm what this thing can vent. And I said that's what those vents are for, is to keep these from exploding. These are designed to not explode in every engineering aspect possible. Now, lithium iron phosphate is not known to catch on fire, but other batteries similar to the li-poly, they can off gas and have a trigger point and catch on fire. You could have a thermal runaway event, in the cell, similar to something exciting everything in there, and get a thermal runaway, cause it to vent and have the ignition source. Then it could, could burn. It'd burn everything out of it. But as far as exploding, I mean, highly unlikely. And most of your incidents involving lithium battery fires, that's right, it's usually a fire. That's from a deflagration off-gassing event. So, they vent their gases off, then there's an outside trigger source, and that's what causes them to burn. The flame comes back, starts them on fire, like you see the EVs on the side of the road that the firefighters can't, get put out. And as the pager story developed today, most experts are weighing in thinking that the pagers were pre-sabotaged with some kind of explosive. So, that leads less likelihood, even more, that the lithium batteries were the source, some technology, and then besides, they weren't all in the same place. So to lay out some kind of electronic warfare that would be able to excite all these batteries all over the place, I find that highly unlikely. And then another thing about the electronic warfare, some device that was exciting the atoms and electrons in here, just think of how much energy that would take. How could you broadcast that much energy through the air to excite these batteries to the point of failure, like something like this? Now, maybe the little li-poly battery, maybe you could, but I don't know, that'd still take a lot of current in that to overexcite it or overheat it. Now, some kind of frequency resonance, maybe making electrons, shake around in there and excite them to the point of overheating, But what I do know is that these cells right here, it can hold 100 amps in, 100 amps out, day in, day out for decades. And car audio people can pull 800 amps out of this cell right here. 800 amps of energy. That is gobs and gobs of energy. Something come through the air with the right frequency to excite this, knowing how much energy they can charge and discharge with, that points more to no, that it can't happen. Now, what would worry me more personally as an off-gridder and a preparedness-minded individual is that the smart BMSs they're putting in with all the Wi-Fi and Bluetooth stuff, that would worry me more than the actual cell exploding or catching on fire. If you're wanting electronic warfare on lithium batteries and off-grid people, that's what you would hit, would be the battery management systems that are in these batteries. Now, this battery is not a smart BMS, but you've seen some of my videos with smart BMSs. Now, those could be hacked, especially using third-party apps from other countries. That's why I don't use apps and things like that, connect to any of my batteries, anything like that. So that would be my concern if you're looking for something to help yourself in preparedness-minded state to prevent any kind of issues with your batteries, is don't use smart BMSs, don't use apps, don't connect your stuff to the internet. That would be my recommendation. Stories develop more through the day too about the pagers overseas, and more experts are weighing in that know more about explosives than I do, because I said that's not my specialty, and they're all pointing to the pagers coming from a single source. The pagers were sabotaged with hidden explosives, things like that. So I'm going to run with that for now. And if I see something else that's more battery related, I'll update you. So hope you enjoyed the video. Way different than normal, but just trying to share you some information on lithium batteries. Y'all have a nice day and be safe.